Yes, good afternoon, everyone. Yesterday, we have discussed about the syllabus that we are going to cover under the CCNP routing. Now, I told you the first topic that we will start is packet forwarding and packet flow. Okay. For understanding about packet forwarding in layer 3 forwarding, just we will see first what are the steps is required in the layer 2 forwarding when you have only one switch and multiple end devices. Now, let's consider that here we have three PCs. It is going to have one IP as 10.0.0.1. Second PC is going to have IP as 10.0.0.2/24 only. And third PC is having IP 10.0.0.3. Okay. Now, if for example, PC1 want to communicate with this PC3, what will happen? First step, that first this particular PC1 will send this information to whom? To this particular switch. Okay. Now, in this case, what happens that this PC1 want to communicate with PC3. And as you are seeing here that we have only one switch, it means that in the same local area network, if they have to communicate, what they require? MAC address information. Okay. Now, this particular PC1 require the MAC address of the PC3. Now, for this, it is going to ask to whom? For this switch. To this switch, it is asking that, see, I want to communicate this PC3 who is going to have a IP 10.0.0.3, send me its MAC address. For that, it sends one ARP request message, right? What it sends? ARP request. Now, ARP request it is sending. Now, what happens that what this switch does? What this switch does? It broadcasts. Now, why it is doing this broadcasting? The reason because it is not knowing where is this particular 10.0.0.3. Because let's consider we have certain interfaces F01, F02, and F03. Now, if they have not communicated, means how switches maintain the MAC address? It maintain the MAC address with port number and the device connected with that and the MAC address of that particular device. Then how it is learning it? Automatically, dynamically. This is a process how it maintains the MAC address. Now, if at present no devices has communicated, that's why switch is not maintaining any MAC address table. In this case, what happens that when it receives the message from this PC1 that it want to communicate with PC3, in that case, switch says, I don't know where is PC3. If you don't know where is PC3, what it does? It is going to ask who is PC3. For that, what it does? Broadcasting. But the actual term, what I told you, unknown unicast flooding. Who does this? Switch will do. What does switch this? What does this switch do? It is going to send an unknown unicast flooding message asking whoever is going to have this 10.0.0.3 IP reply with its own MAC address information. Okay. Now when this sends, so it will also receive the unknown unicast flooding message. In that case, this PC3 will come to know that this question was asked for me, so I need to reply. When this PC3 will reply, the switch will send this information to whom? To the PC1. Okay. So in this, what is happening? First is ARP. Now you know what is ARP. What is ARP? ARP stands for Address Resolution Protocol. it is used to find the MAC address of the destination device with the help of known IP address. So it is a protocol that is used to find the MAC address of the destination device with the help of known IP address. Now, how it is known IP address? Because here this PC1, PC2, and PC3 were knowing the IP addresses where I have to reach. But in the local AD network, if they have to communicate, they require MAC address information. And for that, it is going to ask to the switch. But the switch is not having that information. That's why it sends unknown unicast threading asking to everyone. Now, whoever is having this particular IP will respond with its own MAC address, and this information will be delivered to whom? To the particular PC, whoever has asked. Now, it means that for the first time, if they are going to communicate, what will happen? Broadcasting will happen. Now, for the second time, if they again PC1 and PC3 want to communicate, what will happen? Unicast, because they know each other MAC address information. Okay. Now, one more question. Let's say for the first time, if PC1 wanted to communicate with PC3, so it requested for the ARP. Now they have received the ARP information of each other. Now, for example, if again in any case PC3 want to communicate with PC1, in that case again ARP request is required or not? Not required. Correct? Because already they have communicated. Now you know that whenever this information is being exchanged, so it is going to have certain expiration of the time, right? Like whatever the MAC address information that is being present on the switches, it has certain time limit we have. What is that default time? 300 seconds in on the switch regarding what MAC address table. Okay. Now, can we modify that? Yes, we can modify that. We can change the default timer. That is called as what? Max age timer. Max age timer on a switch. Okay. So in this case, that first is going to be called as ARP request. And ARP request is in what form? Broadcast form. Once the message reaches, ARP reply will come, and ARP reply is in what form? Unicast form. Now, how you identify that this is a broadcast message, ARP request message? With the help of one code 01, and this one will be identified with the help of one code that is called as a 02. Now, one more question. Okay, fine that it is doing the broadcast info. It is doing the broadcast, fine. Now, what happens now that whenever ARP request is generated, so it says that the target MAC address is unknown. Okay, the target MAC address is unknown. It means what? Right? And somewhere you will find the target MAC address is all F. Do you know this? That what happens that what is the reason of this asking the MAC address information? Because ARP request is in broadcast form because it is knowing that I don't know that. So it is asking everyone. This information is also present. And even this information is also present. The target MAC address is unknown and somebody will find the target MAC address is all F. So my question is, where do you find this target MAC address is unknown and where do you find the target MAC address is all F? Both the cases in broadcast only, but depends in the header. I'm asking in which header you will find this is the information. So in our header, what we will be having? All F we will find where? This is in the Ethernet header. And this is in ARP header. Have you checked this? If you will check in the Cisco packet tracer, it will show you. You can capture the packet and you can verify this. Let me show you. Now come to this PC first. Desktop, IP configuration. IP is what? 10.0.0.1. Desktop IP configurations. IP is 10.0.0.2. Desktop IP configuration. IP is 10.0.0.3. Okay, now come to the simulation mode. Then come to this first PC. Come to command prompt ping. Come to real time first. Ping 10.0.0.3. This is ICMP and this is now you see here. What is it in? Ethernet header. What is the source MAC address? The MAC address of the particular device. And what is the target MAC address? All F. All F means what? Broadcasting. Now you see in the detail. What it shows here, Ethernet. This is what? Destination MAC address. Sorry, this is an address. And see here, this is what? Target MAC address all 0. So where I find this target MAC address all 0? In the ARP header. Where I find destination address as all F? In the Ethernet header. Fine. And this is what? Opcode, where you will find that 01. So 01 is what? Echo request. And for that, you will get the echo reply. And that is, sorry, not echo request, means ARP request. ARP request it is. And for that, you will get ARP reply. That is going to be called as a 02. Now you see what will happen. This message delivered to the switch. Now what this switch will do? Broadcasting. Both the devices receive. Now what will happen? It is going to drop this message, right? Because this is not the 10.0.0.3. Now this one will reply. Now when you will see here, it received the MAC address information. Now it is showing you that this is the target MAC address and this is the now who is going to receive this information, that MAC address. All these things is operating on which layer? Which layer it is? Layer 2. That's why we call ARP as a layer 2 protocol. Right? No? ARP is a layer 2 protocol. But when you will discuss the practical implementation of the ARP, you will find that as it is involved in finding the MAC address with the known IP address, in this we can say that practical implementation is between layer 2 and layer 3. Around 2.5 we can say. But actually it is a layer 2 protocol, but practical implementation is between layer 3 and layer 2. Right? For example, there is one protocol called as a point-to-point tunneling protocol. Okay, that is responsible for establishing a VPN connection between the source and the target destination. Now, that point-to-point tunneling protocol Actually, it is an application layer protocol, right? But it also has implementation in the session layer. So we can give an example of session layer protocol as what point-to-point link protocol, correct? Same as here also we can say that what happens that though it is a layer 2 protocol, but actual we can say implementation is between layer 2 and layer 3 because it knows the IP also, and with the help of known IP only, it is going to find the MAC address information, correct? Next, it will receive the information. Got the got it? Now, next what will happen? ICMP will be sent. We'll come to ICMP later on. Just first we will be seeing here the ARP information. Now you come to this PC. Now you can check with a command ARP space hyphen means A. Yes. Showing you what is this? The IP address of the device, the MAC address, and how it is learning dynamic. Now this is the command you can use to check. Yeah. And if you want to check on the router, because you know that switch maintains what? MAC address table. If you want to check it on the router, then what is the command? Show R. We'll come to that also one by one. Till here it is clear? Okay. Now we'll take one more scenario here. Now we'll take a router, one PC, then one switch, one more switch, and a PC. IP on this interface is 192.168.10.1. Next IP on this particular PC is going to be 192.168.10.2 slash 24 by default, you can understand. On this interface, the IP is going to be 192.168.20.2, 20.1, and for this PC, the IP is going to be 192.168.20.2. Okay, here we have interface number as let's say F0/0, and here we have interface as F0/1. Fine. Now, you know that if this PC, let's say this is PC1 and this is PC2. So this is PC1 and this is as PC2. Now, if PC1 and PC2 has to communicate, can you explain me all the packet flow, what will happen? All the steps? Huh? First, this PC1 will generate ARP request. Then it will reach to the default gateway. And then router, what will router do? You are telling proxy ARP. What is proxy ARP? Huh? Okay, fine. So that here you are telling that PC1 and PC2 are in different network. Now, in that case, if they want to communicate First, what is going to happen here? ARP request will be generated. Okay. Now, if ARP request is generated there, then what will happen? Will this router will do? Router will reply with its own MAC address. And what this is called as? This is called as proxy ARP. Hmm? Again, explain me. PC1 is going to generate ARP request. This ARP request message will reach to the router. What this router will do? Instead of giving the MAC address of the PC2, it gives its own MAC address. Correct? This is called as a proxy ARP. You call this as a proxy ARP? Yes or no? Yes. The PC2 in different network only. No. See the network address. Then it is a proxy ARP. Okay. Okay. Now you have to understand the actual concept of the proxy ARP. See what happens. Let's say on the PC1, you have not configured the default gateway information. Okay. On the PC1, what is not there? Default gateway information is not there. In that case, if default gateway information is not there on the PC1 and you are trying to reach to PC2 with the IP 192.168.20.2, so don't you think that PC1 does not know where is my default gateway? So it is going to ask directly to that 192.168, or it cannot ask to the default gateway. It cannot ask. Now, in this case, if it cannot ask the default gateway, then how your default gateway will reply? Or let's say one more scenario. For example, if PC1 is having the default gateway information that if I want to reach 192.168.20.2, then as this PC is in different network, so I cannot reach there directly. For that, who will help me to reach? Router will help me to reach. And even I am having the default gateway information. So it is going to ask to the default gateway directly that see, I want to reach 192.168.20.2. You send me your MAC address. I will send the data to you. And this is your responsibility now to send this information to the PC2. Right? So in this case, what happened? Instead of getting the MAC address of PC2, PC1 is getting the MAC address of whom? Router. And this PC1 is even asking to whom? Router. This is not a proxy ARP. Okay. This concept is not called as a proxy ARP. Why? If I am asking to the default gateway, if default gateway is only replying, then how we will call it as a proxy ARP? This is not a proxy ARP. Then what is a proxy ARP? Right? If instead of asking to the default gateway, if this PC is asking to this PC that send me your MAC address, and in this case, if this router is replying, then this is the proxy. It means what? It is based on what? Condition. Condition is this particular client device, end device, is asking the MAC address from whom? Either default gateway or to the PC. In that case, it depends whether it is going to be called as a proxy ARP or not. Now, you will ask in what situation this particular PC can ask this one instead of asking to the route. A situation can be when default gateway information is missing. A situation can be, let's say, this particular PC1 considers that this PC2 is in my same network. How it will happen? One scenario I'm giving you. Okay, here only I will write. You understand the scenario? For example, here the IP I have given you 192.168.10.2. Okay, let me show you phrase only. Same router, then one switch. Here also one switch, one PC, one PC. IP on this particular end device, PC1, is 192.168.1.150/24. Okay. Now you tell me what is the network address for this IP? /24 it is. What is network address? Fast. Yeah, network ID. Right. So it is going to be network address is 192.168.1.0. Okay. In this case, on this IPC, I'm giving one IP 192.168.1.151/25. Now you tell me network address. Huh? Same or different? That's why yesterday, when I was discussing one question, I told you that you have to know network, how to find network address because this is routing. In routing, you have to know how to find network address of the given IP. Today, you revise all these things, right? 192.168.1.128. How you can verify this? I'm not going to explain you. Already I have explained you yesterday. Now, this IP belongs to this network. This IP belongs to this network. It means network is changed or not. Network is different. Now, if you will observe on the IP, it is written 1.50 and it is written 1.51. Now, this PC will consider that this second PC is in my same network, but actually it is in different network. It considers that this is in my same network, but actually it is in different network. Now, when it considers it is in same network, in that case, it is going to ask to that particular PC only what is your MAC address instead of asking to whom? To a default gateway. It means it should ask to whom? Default gateway.